Okay, well, I would think Kayla's with her, but I already quit, so I'm working at Southern Solutions. It's behind Little Tree.
Aha. So I think we already talked about this. This right here, this figure kind of looks like this poster over here. And I said that, well, some things you need a telescope to look at or to kind of make them pop out. And can you just, by looking at this, let me pull up my pen. Like, you see these, we have a bunch of globular clusters. So what I'm circling first are globular clusters. Now globular clusters, the cluster part goes with stars. Do they look like a cluster of stars? Okay. There are other types of clusters of stars, but that aren't globular. They're called open clusters. But these are one of my favorite sort of thing. It's called a globular cluster. It's just an assortment of objects that actually, like the slide says, an annoyed Professor Messier back in the 1700s in France was annoyed with these objects and asked his undergrad students to catalog them so he'd stop going through them. As they cataloged them, they said where they were in the nighttime sky. Okay. So other things then, these kind of colorful things would be nebula. I'll write that out, nebula. Okay, so these other things that I'm circling would be nebula. We have different types of nebula. Nebula in outer space is basically a cloud of gas. That's what a nebula is. And then another thing we see are galaxies. Can you kind of see? I don't know if you tell from your point of view, but these are galaxies. Sometimes galaxies are face on like that, and sometimes they're edge on like this. So we have globular clusters, nebula, galaxies, little wispy things that mostly you need a telescope to look at. Has anybody in here ever heard of the Seven Sisters? Little group of stars, Seven Sisters? How about the Pleiades? Yeah, okay. So the Pleiades actually are associated, they're a little tiny group of stars, they're cute. We'll hopefully be able to see them this fall. But the Pleiades are up here too. They're a cluster, not a globular cluster. They are an open cluster right here. It's Messier object number 57. So I feel like we kind of hit this topic before, and actually on your unit exam, which is not made up and all that, but one of the things I'll probably kind of ask you is, do you kind of know where we're at? So we are a planet orbiting the sun, a star, okay? And we'll talk a little bit more about our set of planets called the solar system. I have a little video to show you on that. And then, of course, our star is a member of what? What's this one right here? The Milky Way galaxy, exactly. And one of the videos we watched kind of talked about how galaxies like the Milky Way, the Andromeda galaxy, and all that, they are organized into actually clusters. We're a type of cluster called the local group. And then they are further clustered into superclusters. Okay? When I say they, I mean galaxies. Okay? So that's amazing. Our solar system, right? Actually on your test, and again, some people have test anxiety, so I don't mean to make anybody anxious. Yes, you will be having a test. At some point soon, I'll kind of give you an estimated date of that test. But on your test, what I usually ask, either multiple choice question or even a short answer, what's the order of the planets? So you just know it's going to be there. So what's the closest planet to the sun? she's doing the same thing I learned. Okay, so I think it was I put very educated.
Oh, I didn't either.
And then mother, and just served us. And it used to be 9 pizza pies, and now it's going to be nothing.
Oh, it was nachos pleasantly for us.
Oh. Okay, so closest planet. Mercury, and then Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Nothing, yeah. What's still, and I'm say used to, what's after Neptune? Pluto. Anybody know what Pluto is now? It's not a planet.
Dwarf.
It is a dwarf planet. It's adorable, and we love it. Are there other dwarf planets?
Apparently so.
Yes, there are definitely other dwarf planets. Okay. Anybody know what Sirius is?
What?
Sirius? This guy right here. This one.
No.
Okay, Sirius. Sirius actually is an asteroid in the asteroid belt. I don't know if it's up here. Anybody know where the asteroid belt is?
Yep, right between Mars and Jupiter.
It is. Yep, right here.
Which is why it's hard to go past once.
Well, that's why it's hard to go past Mars. Actually, those asteroids are all kind of crumbly there, but they're wide apart, though. They're pretty, but it is something to think about. So I'm going to play this video for you, and we'll be talking more about the planets, but this is kind of a nice little video overview of the planets. So I did record Friday, and I look like I'm surprised. The recording actually did go through and everything, and I posted it on our Canvas page. So I changed our Canvas page around a little bit. So the first thing you see, or one of the things you see, is that Twitter feed. So it's on there in case you want to see it. Now this isn't a video, but I like it. See what you guys think. It kind of shows perspective. So do you know how, like if you look at a video monitor like this, they have a little, they're broken up into pixels. So like a little dot is a pixel.
Yeah.
So this says if the moon were the size of a pixel, what would that do relative to everything else? And so I think I'll go ahead and swap these out. So this is just a website. Oh, the other thing I did this weekend was to start a page in Canvas for all the movies that we do. They're out there now in case you want to take a look at them. So the way this works is if I scroll my mouse, it's going to go this way. Okay, so a pixel, I don't know if you guys can see it. Can you see the little dot right there? Okay, that is the moon. All right. So based upon that, of course, we start with the sun. What are we going to get to next in the solar system? Mercury, right. And up here are the symbols. Like that's the symbol for Mercury. Wait, that's the symbol for Earth. Oh, that's the symbol for the sun. Sorry, final answer. Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Okay, so, yep. So actually this is drawn to scale, so you can already see the sun's a lot bigger than the moon. No kidding, right? Well, let's see how big Mercury is. And actually this is to scale with regard to distance. It says that was about 10 million kilometers just now. Are we there yet? So one of the things that I like this little thing points out is, how do I say this? There's a lot of empty space in our solar system. And then you figure if you look at pictures of our Milky Way galaxy, pretty empty space out there. If you look at the picture of our Milky Way galaxy, you just kind of see a blur of light. And of course, one little speck is the sun. So it just kind of shows you this. Here we go. Keep scrolling.
Not even to Mercury yet.
Not even to Mercury yet. Here comes our first planet.
Psych.
Drum roll. If the moon were the size of a pixel. Mercury. Whoa! It's not very big. There it is. Blink and you'll miss it. Okay. Now, one of the things about Mercury, Venus, Earth, and Mars is they're what we call the inner planets. So, and they're pretty close together. So if this is close, watch out. Okay? They're relatively close, and they are inner. And these are far spaced, and these are outer. Okay.
There's like supposed to be another planet behind Pluto that we can't see.
I heard recently that they're looking that there might be another planet, a full-fledged planet out there beyond Pluto. Remember the other day I talked about how all the planets orbit the sun kind of on a frisbee or a disk or something like that. And if you keep going out beyond Pluto, yeah, they're seeing evidence of something that's massive enough and has cleared its orbit, unlike Pluto, to be classified a planet. So.
Man, that sucks. We have to jump over Pluto to get to another planet.
Well, there's a shortcut on this, so I'm going to go to Venus. Hold on.
Oh my.
I know, right? That was much better. Whew. So size-wise, what would you say about Venus and Mercury?
Venus is a little big.
Venus is a little bigger, exactly. Here's a symbol for the Earth. Actually, Mercury and Venus have no moons. The Earth has one moon. And there's the moon the size of a pixel. We're going to fast forward to Mars. Yeah. And can you tell the size of Mars to the Earth? Do you remember? It's smaller. Yeah, Mars is a little smaller. Yeah. What comes after Mars? Jupiter. Asteroid belt, Jupiter. Yep. You guys are, I say, lucky. All right, so check out Jupiter size. It is pretty big. Yeah. Yep. You can see the names of the moons. And these are just the 4 big moons. We call that collectively the Galilean moons. Guess which scientist saw them through the telescope? Galileo. Yes. And he drew like sketches. He's like hardcore science. It's pretty cool. Yep. So there's Jupiter. If Jupiter had been, I forget, 7 times maybe more massive. If Jupiter had more mass as our solar system began, it would have been its own star. It's 75 times more massive. Well, we'll see what the statistic is. So what comes next? Saturn. And what did I say about space between Jupiter and Saturn? There's a lot of it. Saturn's a little bit smaller than Jupiter. You can see Titan, one of its planets. What color, so we're going to Uranus. What color is Uranus and Neptune? They are blue. And they're blue because they have the same chemical in their atmosphere. They have methane. Uranus. And let's compare. So try to get a fix on that size. Let's see what Neptune looks like. They're similar sizes. I couldn't tell much of a difference. What do you think? How many people think that Neptune's bigger?
I think it might be
Smaller? A little bit smaller. Okay. Pluto, Pluto, Pluto! And it wasn't its size that did it in. Pluto, it wasn't its size. But it was, it says we still love you.
Might as well stop now.
Aw.
I knew you keep going.
I think probably this little
Don't
area.
listen to them. There's another planet back there.
Don't follow the system.
They're hiding
Nah.
it. That they're gonna find another planet and so they're gonna have to add on.
So that kind of puts in perspective our solar system. I thought they did a good job. So that's our solar system. So the planets orbit the sun. That's just a member of a group of stars in the Milky Way galaxy. A group of stars. So how many stars are we talking? Well, in general, galaxies contain like 100 billion stars. More than 100 billion stars. I can't either. I cannot comprehend that. So this is a Milky Way galaxy, 100 billion stars. And do you remember, so what did I say about, do other stars have planets? Most of them. And then that's one galaxy, and we have all these other galaxies. Just maybe 2 or 3 years ago, they updated the number of galaxies that were in our observable universe.
That's a big jump.
Yeah, from 100 billion to 2 trillion. So anyway, that's a lot of galaxies, a lot of stars. Let's see if this goes. Guess it won't. Okay, so back to our Milky Way galaxy. You're going to see here and there a few pictures that I took of the nighttime sky. But you can see this is the Milky Way. And on the maps that I gave you, remember, it's kind of that kind of gray bit. Anybody in here ever seen the Milky Way? Maybe not this good, but you might have seen it, yeah. I bet you have, because it's just kind of, you look, and it's called kind of maybe averted vision, because you'll kind of look over there, you're like, well, I see kind of, that looks like the clouds are setting in, but you look at it and you're like, well, those clouds are in a straight line, and you're like, well, those clouds go from horizon to horizon, and that might be the Milky Way. If you have a pair of binoculars, just look to see if it's like hundreds of stars. So this is kind of talking you through a little bit about the organization of our universe. So planets orbit stars, stars are in galaxies, and then galaxies hang out in clusters. It's funny because I'm like, so the Milky Way galaxy is a group of galaxies called the local cluster. Like, how original is that? And our supercluster is a local supercluster. So here's a few pictures. This was something I took. You can barely see it, but sometimes it's just like, I got you. So this isn't a face-on. This is an edge-on galaxy. You can hardly see this. This is a triplet in the constellation Leo of galaxies that are high to see. This is a face-on galaxy. Yeah, this is a galaxy. This is like what they call low-hanging fruit in the photographic world. This is Andromeda. True. I did that. The center is the center of the galaxy. It has a supermassive black hole like ours. Now, I do want to play this video for you. I opened up kind of this part asking you if anybody knew Carl Sagan. Most people did not, but some of you guys know Neil deGrasse Tyson, who's kind of taken Carl Sagan's place. But this is Carl Sagan. And check out these crickets. I moved that wastebasket, and there's like 5 or 6 crickets back there. I'm like, I'm not going to do that. I know. I don't mean to gross anybody out, but that's just too much for me.
There was one outside of 302 at the beginning of the
Chirping away?
Yeah, just walking around.
Yeah, it's something. I don't know. I don't want to like kill them necessarily. So, what's this, you think? The Milky Way. Yep, this looks like the Milky Way. Now, sometimes the Milky Way will kind of go like this, but as we, and this is the sun, and this is the Earth, as we orbit the sun, we're going to see different things in our nighttime sky. If we just take that further, so this is the sun, and this is the Earth. How, you guys told me, how long does it take for the Earth to do this one time? Yeah, a year, 365 and a quarter days. Okay, you got it. So if I'm over here, if the Earth is over here, can you see at night, this is the sun, at nighttime we're going to see that stuff, right? And then 6 months later, I should be doing counterclockwise. I think I am doing counterclockwise. So 6 months later, it's over here, and now we see that at nighttime. So that's kind of why our nighttime skies change, in a nutshell. Okay, so there's too many R's here. The orbit, the word revolve and orbit are the same. Revolve is equal to orbit, and rotate is equal to spin. Okay, too many R's. So the Earth orbits the sun once every year, and the Earth also spins or rotates on its axis. And then how long does it take it to do that? A day, exactly, a day. It's kind of cool because if you look into it, do much looking into it, they'll tell you that the Earth used to spin a lot faster and it's slowed down over time. So taken further, what do you think it's doing now? Is it staying the same or is it speeding up or slowing down? It used to be a lot faster, now it's a lot slower. It's slowing down even more, yeah. So for people who say, I wish there were more than 24 hours in a day, well, guess what? The Earth is slowing down ever so slightly. So if we define a day as one rotation, and rotations are taking longer, it'll take a while though. I wouldn't say you're going to get an extra hour in your day tomorrow. One of the things that we'll be talking about, I do have it in here, right here. And I think it's in the next part that we'll hit Wednesday. But whenever I hold this up here, this is the stick that the Earth spins on. It's called the Earth's axis of rotation. So this is the sun, and the Earth is spinning on its axis, okay? Now the thing about its axis of rotation, let's see, where's north? Okay. The thing about its axis of rotation, it is not perpendicular, it's tilted, like you see up here, and I guarantee it's going to be on your test somewhere. Instead of being like perpendicular, it's tilted 23.5 degrees. Now you're like, what do you mean by 23.5 degrees? So if this angle would be 0, okay, this is 23.5 degrees, okay? Yeah, roughly. So this would be what, 45? Okay, and this would be 180. Okay, so 23.5 degrees. And we'll talk more about this when we talk about seasons, but I asked which direction north was because of this. If I'm going to make this little stool the sun now, of course the Earth orbits the sun once a year, he told me. Its tilted axis of rotation always remains pointed to a star, starts with the letter P, it's our North Star.
Isn't that Polaris?
Polaris, it is Polaris, yep. Okay, so it's Polaris. So check out how I'm going to do this, okay? I'm going to go, this would be, actually as it turns out, this is summer. So this is like June for us, June. And then 4 months later, we're into September coming up. Check out my tilt though, okay? And then 4 months later, we're in December. I'm tilted this way. And then 4 months later, we're in March, okay? And it always keeps the same tilt like that. Now, of course, the Earth is rotating 24 hours like that, but this 365.25 days goes like that. So that's the Earth's tilt, and again, we'll be talking more about that. But so, can you kind of see what I just described here? Okay, cool. The 23.5 degrees. This would be, as it turns out, this is June over here. June, and you can kind of see it's going counterclockwise. So this is September, and this is December, and this is March. I'll go ahead and, I'm bad about knowing whether it's the 21st, 22nd, or 23rd, so I usually put 21st through the 23rd, and then I catch it, 21st through the 23rd. But it's a real date, but I don't like to memorize it. Those dates that I have, those calendar dates, correspond to the summer, okay? What we call the summer solstice. This is the fall, what we call equinox. This is the winter solstice, and this is the spring equinox. So we'll be talking more about that. We kind of got a precursor to that. So it's what I think is interesting is like folks before the scientific method, folks who, people who used to not have TV, okay, and not understand necessarily science. Travel was difficult. So without travel, you can't really communicate with each other, but they would tell stories and they would see the sun rise. Let me get my east and west right. Okay, so that's east, does that sound right? Okay, the sun would appear to rise in the east and set in the west. Now we know that that's actually because the earth is rotating, the earth is spinning. Guess what? The moon would appear to rise in the east and set in the west. Okay? Planets, as it turns out, to a certain extent appear, what planets? Stars. I would say stars, to a certain extent, appear to rise in the east and set in the west, to a certain extent. And again, that's all related to the Earth spinning on its axis. Now, the thing about stars, though, and I've already told you, like over hundreds of thousands of years, stars have kind of changed their relative location. But for us, on a night-to-night-to-night basis, for our lifetimes anyway, we're going to see the Big Dipper, for instance. The Big Dipper is going to be the Big Dipper for our lifetime. So those are kind of certain things that we see in the nighttime sky. The thing about stars, and we'll be talking more about it, but the stars that make up the Big Dipper, my hand is the Big Dipper, they actually they look like they're kind of on a sheet of paper like this, but like this one might be farther, this one might be closer, farther, farther, closer. So they're at different distances from us. Okay. I'll talk more about parallax coming up. And we already talked about the Milky Way. The darker the sky is, the more likely you are to see the Milky Way. If the moon, as it is right now, I don't know, gosh, did you see the moon? It's kind of got this pretty orange glow to it right now. Very pretty. The other thing about the moon, though, is if you can actually, if the moon's up there, you can actually make a puppet. You can make a silhouette, It's like, it can cast a shadow, the moon's so darn bright. And with that brightness makes it hard to see things, including the Milky Way. That's what it's going to say.
It will be really pretty tonight because Mars retrograde ends today.
Okay, Mars retrograde ends today, so it's a good configuration with the moon?
Yeah, they're like, it's just going to be good.
Okay, go check out the moon, find that little orange ball, it's Mars. Sometimes on the test, I've asked a little bit about constellations. Now, before your test, I will give you like a handout that kind of narrows down stuff, and I'll probably record a little what I call a review session so you can watch that if you want to. But let's see, winter triangle's not up right now. I'm going to use my pen to circle a few things though. This guy, and we'll be seeing more about it, I don't know why, this constellation just intrigues. It's just beautiful, Orion. Now, Orion has these 4 corner stars. One of the stars is named Betelgeuse, and then these, and I know Rigel has those 4 that make out kind of the outline. It's got, this is what we call the belt, and this is what we call the sword of Orion. Very cool. Orion has a dog. The word Canis is dog. So we actually have a tiny little constellation. But it's bigger than, what was that constellation we saw? Telescopium. Canis Minor is bigger than Telescopium. So we have Canis Minor up there that has a bright star called Sirius. Oh, no, Canis Major has a bright star called Sirius. Canis Minor has a bright star called Procyon. Thank you. And then the big dog down here, Canis, meaning dog, major, big. The big dog has the bright star called Sirius. So you can already kind of see a little bit about, constellations. And some stars have awesome names. The brighter the star, the more awesome name it has. The star Betelgeuse is in Orion. The star Sirius is in Canis Major. The star Procyon is in Canis Minor. And it makes up what we call the winter triangle. So near the end of the semester, we should be able to see that one. On the slide, it talks about, for us anyway, for our system of constellations, we have 88 constellations. So the nighttime sky is broken up into 88 chunks, but they aren't necessarily the same size. So Telescopium has a small area, and Orion has a bigger area. Okay, so they aren't equally divided. And see different constellations for different cultures. That makes sense. Man, I already talked to anybody look at Stellarium over the weekend?
Not yet.
Not yet? Okay. It's with an A, Stellarium with an A. I still need to fix my view. So here's Orion. And I think I will go ahead and dim the lights because we'll see Orion is one, especially this fall, that I want you to be able to enjoy. That's better. So the 4 stars, this is Betelgeuse, and this is Rigel, and I don't know, I should know what these are. My astronomy friends at the observatory probably know, but you can kind of see when I talk about his body, and this is the belt, and this area is the sword. Okay, so pretty cool. This actually was something, I think I will kind of take us out and road trip. We're going to talk about parallax. This is trying to talk about parallax. We have, for parallax to happen, and again, I think we're gonna go outside for you guys to experience parallax. But for parallax to happen, just like you see on the screen, we have the mountains that are the background. We have the object of interest, which are, what is the object of interest? Well, could either be the trees or the guy. Okay, so let's make this the trees or the guy. And then we have the observer. And I'm using my hand. So this will be my observer. So the background, the object of interest, and the observer. According to parallax, the farther away the observer is from the background and the background and the object of interest, the farther that distance, the more that if the observer moves from side to side, they're not going to see much of a difference here. Before we go outside and try it, this will be one of our last things to do. We're going to do it in here, and this really works. Everybody has a dominant eye and a non-dominant eye. So, let's see, how does this work? So, everybody do this. I'm going to look at that clock, and you guys find something up here to look at. And so you're going to hold your finger in front of your nose. And first off, let's do it where you extend your arm, okay? And then kind of center your finger in front of the object and close one eye and close the other eye. If you can't close your eye, go ahead and cover it up. Do you see it move? Okay.
I did this for fun.
For me, I see it move not very much when I'm looking with my right eye. It moves very little. When I'm looking with my left eye, it moves a lot. That means my right eye, where it moves very little, is my dominant eye. Now, to see parallax, what we need to do next is to take your finger now, kind of still keep it centered on the object, and now pull it near your nose, and then open and close an eye. What happens? What happens? Is it closer, or does it scoot farther away? Farther away. And that's what I was trying to describe. When the object of interest is closer to you against the background, you're going to see it move. You're going to see it relocate a lot when you change from side to side. In this case, changing from side to side is going back and forth between different eyes, versus if it's far away. Okay, so we're going to go out to the courtyard, and you can take your stuff if you want, because I think we're going to be done after that. Or you can leave your stuff. Out to the courtyard. That box rolls.
47.
I have one again that sits me right now. I want to see if this is extra small. I'm okay.
I didn't go to the gym. And I didn't. Got my ass and blew it on the pool. I liked it.
Oh, I'm so ready for class tomorrow.
Oh, yeah.
Sit space.